Chapter 9, Electrons in Atoms and the Periodic Table. You heard of the Hindenburg? There's a picture of it. The Hindenburg was a dirigible full of hydrogen. Hydrogen is the lightest gas, and so it has the most buoyancy. Unfortunately, hydrogen is also very flammable. Those of you in, we all got to experience the hydrogen in lab, right? In lab this week, you generated hydrogen and caught it in a test tube and lit it, and it went whoop, right? And the Friday people were clever enough to suggest, what if we fill a balloon with the hydrogen? And what did that do? Boom! Yeah, it was a good thing the balloon didn't get any larger. So, back 1937, the Hindenburg burst into flames, killed 36 of its 97 passengers. Tragedy. What we're going to look at is, why is hydrogen so reactive? Why is hydrogen flammable? Other gases aren't. Why is hydrogen? Modern blimps are filled with helium. Helium doesn't have as much buoyancy because it has it's more dense than hydrogen, but helium is inert. You never see the Goodyear blimp exploding over a football stadium. You couldn't make it explode. Helium gas will not burn. It won't make compounds with anything. No one has been able to make a compound with helium. Very, very inert. Why? We're going to learn about that by studying electrons. Are there other elements that are as reactive as hydrogen? Yeah, there are other elements that are very reactive. Hydrogen is put in group 1A of the periodic table, even though it's not a metal. But the other elements in group 1A, lithium, sodium, potassium, are also very reactive. Helium is very unreactive. It's in group 8A, and the other elements in group 8A are also very inert or unreactive. Theories and models of the atom and what the electrons are doing help us to understand and explain what we observe in the behavior of these different elements. So we're going to look at two different models, the Bohr model and the quantum mechanical model. These give explanations for the reactivity of hydrogen and the other group 1A metals and the inertness of the noble gases, including helium. They also help us to understand the periodic law. If you've forgotten what that is, the periodic law states that when the elements are arranged in order of increasing atomic number, certain sets of properties recur periodically. That's why the periodic table is called the periodic table. So as you go across the periodic table and you get to column 8, you get to an inert element. And then you go to the next row and you come across and you get to that last column, it's an inert element. There are properties that recur. The models help us to understand what the electrons are doing and how that affects the reactivity and physical properties of these different elements. Okay, so we're going to be talking about quantum mechanics. And I'm just going to, go out on a limb and say you're probably not going to like it. But you're in good company. Niels Bohr said, anyone who is not shocked by quantum mechanics has not understood it. Schrödinger, that's this guy right here. He was one of the guys who worked on quantum mechanics, Erwin Schrödinger. I don't like it, and I'm sorry I had anything to do with it. Right? This is a scientist. Because these guys are studying, it's really more into physics, but it applies to chemistry. It's also important in chemistry. They're studying nature, and they're observing things, and they're trying to figure it out. They don't like what they're seeing. But you can't just say, well, this can't be true because I don't like it. Albert Einstein, you've heard of him. This is Bohr, by the way. Einstein said, God does not play dice with the universe, because that's what quantum mechanics seems to imply, is an awful lot of randomness. So the quantum mechanical model is very, very important in modern chemistry. It's the basis of the modern periodic table. It guides our understanding of chemical bonding. The applications are mind-boggling, including semiconductor devices, which without semiconductors, that cell phone in your pocket would not exist, and the design of new drugs. And Schrodinger's cat. I have a great video about Schrodinger's cat.